Earlier, we introduced the concepts of projects, models, and packages. In this lesson, we will take a closer look at each, demonstrate how to create these objects, and discuss their uses and importance. Let's look at how to create a model for use in our fleet management scenario. Creating a model involves first starting a wizard and specifying the metadata, such as the name and description of the model. Then we can also choose whether we want to create the model in a separate package or in an existing package. A model created in a standalone package is called an extension model. A new model added to an existing package is called an overlaying model. The selection of the model type will determine the development approach. Finally, we update a model's parameters and set a model's dependencies, which will define the other models it is dependent upon. These dependency models are also called referenced models. Shortly, we will use the wizard to create a model for our fleet management scenario, and then we will create projects to associate with it. There are two options for model architecture: overlaying and extensions. If you choose to create a model in an existing package, you must select the model that contains the elements you wish to customize as a referenced model in the wizard. Creating a model in an existing package indicates an overlaying scenario. This allows you to directly customize metadata and source code in another layer. For example, you can change the design of a form in the var layer or cus layer using an overlaying model. However, because it is tightly coupled with the containing package, this method of customization yields slow compile times and could potentially increase the cost to upgrade to a new version of the product in the future. If we choose to create a model in a new package, this indicates that we are going to use the extension model approach. Development using extensions allows us to access the elements from any models that are specified as referenced models in the wizard. This allows us to add functionality to existing code. We can create new elements and create extensions of referenced elements in our projects. By creating extension elements, all of the customizations and code are stored in a separate assembly which contains only the additions or changes in the extension. Because this code resides in a separate assembly, it improves the performance of building and testing. This approach is also ideal for upgradable customizations as it eliminates metadata conflicts. The startup object property is the object that will be invoked when the project is run, and the startup object type is the type of the startup object. Startup objects include forms, menu items, or main methods in code. The company is the default company that will be used when the project is run. For example, in an empty system, the DAT company would be the only startup company available. The partition property specifies the partition that will be used when the project is run. The project file property identifies the name of the file that contains information about the project. The project folder property specifies the location of the project files in the file system. The model property identifies the model that the project is associated with. This property is particularly important because the project must be associated with only one model, and all elements in the project must belong to the same selected model. The model publisher property is a read-only value that indicates the publisher of a model. The layer is a read-only value that indicates the application layer that the model is located in. Finally, the synchronized database on build property indicates whether the synchronize operation for database objects will be performed when the build action is run on the project.